homework for this week is from section 6-2, which requires you to simplify radicals or radical expressions. So I'm going to go through a few examples, one with product, one with quotient, another one with product but with coefficients, another one with quotient but it has a mix of coefficients and radicals, and then a cube root or a couple cube root. So I hope you find this helpful. So with this first one, we're going to start with, I'm just going to stick to one strategy for all of them. I'm going to start with first with factoring 72 and 16. So I have to think of values that I can multiply to get 72. So for 72, I know that 8 times 9 is 72. Neither of those are prime numbers, so I'm going to keep going. So for 8, I have 4 times 2, and for 4, I have 2 times 2. So I have, I know when to stop once I have just prime numbers, which is a number times itself. For 9, we have 3 times 3, and 3 is a prime number. So the factors of 72 are 3 2s and 2 3s. So now let's factor 16. I can do 4 times 4. It really doesn't matter how you break it up because at the end, you do end up all with the same factors. So for 16, I have 4 2s. If you are a person that recognizes perfect squares, you might have already noticed that 16 is a perfect square, and the square root of 16 is just simply 4. When we are square rooting, we're looking at groups of 2 factors to factor out. So we want to put groups of 2. That's another strategy. So since I know that square root of 16 is a perfect square, I'm just going to put 4 for that one. For 72, any 2 pairs of numbers come out of the radical sign. So I am going to take the entire factors and just put them as expanded notation under the radical. And I'm going to notify that these 2 make a pair and these 2. So for every 2 that make a pair, one of the values comes out. I have 2 left by itself, so that stays under the radical. So if I simplify this, it looks like 2 times 3 square root of 2 times 4. I can simplify further by multiplying all my coefficients. So 2 times 3 is 6 times 4 is 24, and then I have square root of 2 left. So this is the simplest form of the product of radical expression square root of 72 times 16. So now let's look at the quotient. I'm going to do the same thing as I did up here with factoring, prime factoring my 2 values. So I have 95 and 25. So since it ends with the 5, I know that I can do 5 times some value. 5 goes into 95. Let's see, that's 145 left over, 5 and 19. 19 is a prime number, and 5 is a prime number. So that's it for prime factoring 95. 25, you might have noticed that it is a perfect square. We take 5 times 5, so the prime numbers for 25 are 5 times 5. Anytime we have a radical symbol, and it's a fraction, it's the same thing as we write it if we write it as square root of 95 over the square root of 25. Because 25 is a perfect square, I can also write that as the square root of 95 over 5. And I'm going to leave this as a square root of 95 because I cannot simplify it any further since 95 can only be broken up into prime number 5 and 19. Okay, what if we have coefficients and square roots? Just like before, we're going to start prime factoring. So I have 6, which we know it's 2 times 3. 3 is just a 3. So I'm going to take my coefficients and I am going to multiply those two. And so I can write it as 5 times 4 square root of, and I'm just going to put the factors 2, 3, and 3. 5 times 4 is 20. Under this radical sign, I see I have a group of 3, so a 3 comes out. And then this 2 is left without a pair, so that we leave that one under the radical. I can simplify further. 20 times 3 is 60. And I still have the 2 underneath. So the simplified version of this product is 60 square root of 2. Here we have a mix of coefficients, and the coefficients being 3 and 2. As they are right now, I can't simplify. I do want to break up the 6 and the 3 again, which we know 6 was the same thing as 2 times 3. 3 is already a prime number. So I'm going to expand this. I have 3 times square root of 2 times square root of 3. All over 2 square root of 3. This is where it's very similar to reducing fractions. So in this case here, if there's something in the top numerator, or in the numerator and the denominator that I can cancel, I go ahead. So there's square root of 3 in both of them. So those cancel out because it would equal 1. So then if I continue, there's nothing else I can cancel out. So this simplifies to 3 square root of 2 all over 2. I don't change it to a decimal like 1.5 square root of 2. I just leave it as a simplified fraction. What if instead of a square root, we have cube roots? I'm going to follow the same process. I have a factor of 4. The prime factors are 2 and 2. Same thing for the other 4, 2 and 2. One strategy I can do is if they're under the same cube root radical, I can just multiply those numbers or put them under the same radical. So this radical expression up here is equivalent to this one. It's just written in a different form. So I can write it as square root of 3, and I have 2 times 2 times 2 times 2. Because it's a cube root, I am trying to get groups of 3. For every group of 3, one of them comes out, so this becomes 2 square root of 2. Oh, not square root of 2. Correction, cube root of 2. So 2 cube root of 2. And then we might have some that have coefficients out front, some numbers and variables. I'm still going to break it up. So I am going to start with factoring out the 32. So factors of 32 are, I can do 8 times 4. 8, we have 4 times 2. And for 4, we have 2 times 2. And we know that 2 times 2 are the factors for 4. So here we have 5 prime factors. All of them are 2. Because we are dealing with a cube root, we want groups of 3. So I'm going to leave this -5 out here as it is. We have a cube root. So I'm going to write all of my factors of 2. I could easily write it 2 to the power of how many 2's I have. That also works. But I'm going to do expanded form for right now. So we have 5 x's, 1, 2, 3, 4, 5. I'm not going to be able to fit it all. Here, let me try it again. Move it down here. So I have -5 times the cube root of 1, 2, 3, 4, 5. And I have 1, 2, 3, 4, 5. And then y to the third means we have 3. Because we're looking for groups of 3 because this is cube root. I have this group of 3, this group of 3, and this group of 3. Another way I could have written this out is -5 cube root of 3. It made groups of 3. I could have written it as 2 to the third and 2 squared because there's 2 2's left over. X to the third and then x squared. And I could have left 3 to the y. Because a cube root undoes cubing, this one cancels out, this one cancels out, and this one cancels out. For every group, one of those values comes out. So I already had a -5. I can take out a 2. I can take out an x, and I can take out a y. And what's left under the radical that are not perfect cubes is 2 squared and x squared. So I can leave those under the cube radical. And we know 2 squared is equal to 4, and then we just have x squared. So we can simplify more by multiplying our coefficients of -5 and a +2, which is a -10. And then we have an x and a y, and of course the cube root of 4x squared. I hope you found this helpful.